Well, hello everyone, and welcome to yet another live stream. And hi, the Flame. Hi, hello everyone. Welcome to yet another
Hello.
live stream. Guess who just said that he's ready to stream and then completely forgot that this microphone was wasn't plugged in, and completely forgot about download 50 other things. But yeah, hi there. Hi, welcome.
Hello.
The second one in the row. Chemistry. I'm on fire, honestly. Yesterday, I've learned so much from you. Like, you haven't seen the newest script because I sent you the script and then I kept scripting it. But I basically finished the
let me have a
video
look.
in one sitting.
Okay.
And I won't lie, like, wow, I've learned a lot yesterday.
Oh wow, you've written a lot.
Yeah, I did, right?
That's that's a lot in like 2 hours. Oh my god.
I know. I don't know, I'm just having a phenomenal day today. That is an awful lot, isn't it?
Yeah.
Yeah, I won't ask you to read through it right now because
Yeah.
but like everything you told me yesterday is in the script right now. And now the only thing left is the conclusion chapter, which, well, that'll be easy one. Hello everyone, by the way. Hi there, Happy. Oh, Happy, you're on your Happy account. I'm so glad. A good stream number. I know, it's funny, comical. Yeah, hi the lamppost, by the way. Hi Sharma. Hi everyone. Hi, welcome. And speaking of, might as well get right into it, right? So
Yeah.
it was the principal quantum number relation to density, right? Remember?
Yeah, so it was one thing I just forgot to mention. I kind of just glossed over the principal quantum number. I was like, "Oh yeah, it's just the energy level or whatever." And it's like the distance from the nucleus.
Yeah.
Let me find this slide
Just a
because
bit
it
of research.
shows it. Is it here? You might have seen it before already.
No, don't ever assume I know something because more like I've made three chemistry videos, and only yesterday learned about anti-bonding. Okay, so don't ever assume that I know something.
Okay. Um,
The indomitable
this
spirit
one.
is just a human thing. Prove me wrong. It isn't, but I'm just in such a. This is such a powerful post too. I don't know. I just woke up today. Sailed sent me a lot of hope posting memes, and I just had to make it. I'm rendering an awful lot of things nowadays, and because of that, that's the main thing actually slowing down my videos. It's kind of annoying. Won't lie. Because now I'm really excited for the Electron video. I know it's gonna take a while just because of the runtime. Hey, make it. I guess you didn't see my messages in last stream, so I couldn't join your stream a few days before my girl had exams. So I had to give a midnight classes for her doubts. It's fine. I mean, I saw them. I'm sorry for not responding. All right. Whenever I have anyone on stream, it feels so rude to just interrupt.
I don't mind.
Oh, but it still feels wrong. Yeah, okay, fine. From now on, I'll interrupt. I know that you don't mind. I know that Tefta doesn't mind, but it still doesn't feel right.
It's hard to like pick when to read the chat messages when it's like two people having a conversation.
Precisely. Oh, when you're explaining something, I don't want to throw you
Yeah.
off. Like,
I
throw
mean,
off my
I'm
train
looking
of
at the
thought.
chat as well, so.
Yes, I should just got the.
Right, I've got a screen share up.
Just, there we go. There we go. All right, may I show it?
Yep.
I always want to clear up.
Okay, so most of this is like what you understand anyway, about probability density. This graph is like a common graph we use where it's essentially just obviously psi squared is the density because we know psi is the wave function and then you square it to get the probability density. R is your distance from the nucleus. And so obviously when there's no R, you're at the nucleus and the density is the highest and as you go out. So this is a model for like our typical 1s orbital. which looks like this. You know, it's a
That's right.
it's a
So it's
sphere.
represented as a sphere.
Yeah. What I wanted to show. This is more. This is just kind of where you get it from, but you know quantum mechanics anyway. So. This is some of the angular stuff. Don't think that matters. This is nodes. Okay, this is what I wanted to talk about is when you go up from 1s to 2s, obviously your n is changing.
Mm-hmm.
And what you actually get is you can see there's a negative and a positive here. And so you end up with like different phases of the orbital. And there should be a diagram. It looks like this. So when you have like this, when you go up in n values, you add these nodes kind of in between inside it. And so your density looks something like this, where it kind of just wobbles. It wobbles around, and obviously most of the density is here. So this is why we say that the electron's further away.
Yeah.
But this is what's actually happening.
But this is
so
the
we go
probability.
from this.
But this is probability. So actually, you have negative. Well, not negative. Only you have opposite phase, which means.
Yeah. Well, so what the phase comes from this because this dips negative and positive. But then when we square it, we go to probability here. So you can see these turn into these.
Okay. Okay. All right. Once again, I get it. I have no questions.
Yeah. Okay.
You should
I just wanted
things.
to check that with you.
You should explain things a bit worse because I have some questions.
But this thing, you'll see in like any pictures of orbitals or whatever. This is like this kind of pattern that happens when you increase your n, and so it kind of depends on it depends on your L as well. So for example, if you're looking at a 2p orbital, that's the like lowest n you could have for a p orbital, right? Because you can't have a 1p. And so your 2p doesn't have this pattern. It just looks like this, but with two lobes. But when you go up to 3p, it then does have this. And then each time you go up, you kind of add another node, and it just adds these bits here.
So that actually works for every single L. That's
Yeah, it's a thing in every orbital. Or is it for? Don't know if it counts for molecular orbitals, but for like atomic orbitals, yeah.
Well, now I want to check like what the.
Oh, here's a perfect example right here. This is
that's
3p.
precisely what I was gonna look for actually.
Yeah. I don't think they show anymore, but you can like look for them. Here's some example. I don't know why it's sideways, but you can see you have 3D here doesn't have it because this is the first place where you have a D value.
For the
I can.
It's just. Oh, that's much easier. I was just tilting my head. Okay. Yeah, and then 4D has like.
Yeah. So he's perfectly labeled these L values as well. So you can see we've got 3D here, but then when you increase N, you can see there's like an extra layer inside. And 4F, but if you had like 5F, it would have another layer. So you can see how the pattern just follows. It all makes sense.
Do you have in the same? Would you happen to have like how the L number affects the shape? Or is that
that's
complex?
this. Well, what do you mean how it affects?
Because like there is a clear pattern when it comes to the N, right? Which basically means you're adding more waviness. Right, extremely scientific professional term. You're adding more waviness, right? So there's like an extremely clear pattern when it comes to increasing N. Is there something similar for increasing the L?
I think the pattern is you're adding nodes. You're adding, instead of adding a node inside like you do with the N, you're adding these nodes across the whole thing. So you can see when you go from 1s to 2p, what you're doing is you're kind of slicing it in half with a node. And then when you go from 2p to 3d, you're kind of adding another node. It's a bit complicated with 3d because you have this dz squared orbital, but you can see here you've taken a 2p and you've kind of sliced it again. And you kind of just keep doing that. It's pretty much how it goes. You kind of just keep slicing them. And it arises from
so it just
I guess 3D harmonic oscillators.
Okay, so it just gets more complex. That's
Yeah,
Good number of inspiration.
you're adding nodes, which makes sense because if you remember before, when you add a node, the more nodes you have, the higher the energy is on average. Usually, it does vary, but yeah. Um, so that's the pattern. It was never like shown, but to
Okay,
me
I
it
feel
was
like,
like you just
well,
kind of see
then
you're
once
slicing
again,
it.
I suppose I have that to add to the video. Every single day
I
I'm
just wanted to show it because it's actually like a fairly important thing. It doesn't really matter for stuff, but it's important to like know, and especially if you're showing
I
orbitals.
do want to make a whole video dedicated just to waves and wave function because that like a hour-long video just about the waves because to tie together like math of waves, physics, quantum mechanics, and chemistry, and this will certainly be. Oh, that is a really cool graphic actually.
Yeah,
Wow, that's a cool graphic.
this is a. Let me send you the link so you can open it.
Oh, that is a really cool graphic.
I don't know if that website is still up. Actually, I can just open it on stream. Hang
Oh yeah, it is.
on. I don't know where it
The
shows all
Orbitron.
the.
What's an Orbitron?
I think that's just the name of the website. I don't know.
Oh yeah, it is. Okay, never mind. I was thinking I thought it was like there was a genuine particle or something. Oh, that is really cool.
So you can kind of get a feel for how the pattern just increases with L.
Yeah, like one example. I mean, it certainly does get more. It feels like. I mean, yeah, I don't know how to describe it. It's a
Yeah,
very visible pattern, right?
yeah,
Where you can basically slice it vertically or slice it horizontally.
yeah.
Yeah, but it's very hard to describe. I'm certain there is a way.
Mm.
There must be. Oh, this is actually. Wait, now I'm curious. I
Yeah,
don't want
those
to
are the
fall into
nodes.
rabbit
Those are
hole
nodes
this
on
early
there.
on, but I really want to look for basically the mathematical. There has to be an equation for it, like an equation
Oh,
where you
sure.
just
Yeah,
increase the
it
L
comes
and
from. Yeah,
yeah, yeah, there definitely is one. It just I feel like it's too
yeah.
early for a rabbit hole.
I mean, when you look at, for example, the 3D orbitals, um, it's annoying saying 3D because I don't mean three dimensional. I mean the D orbitals. But when you look at these, what you need to well, one of the like weird things that goes on is we have this dz squared orbital, which is like it's different to the others, and I think it just comes from the fact that we have to limit it to 5 orbitals because we're not allowed more than 5 in this box, right? And so what we do is we end up kind of combining. I think it's a combination of dz squared minus x squared, and you add it to dz squared minus y squared, and so you end up with this as like this dz squared is a short name for the actual whole thing because you've essentially combined 2 orbitals to get here. But I don't know exactly how that arises and how it still works. But I know that you've taken like 2 orbitals that look like these, and you've smashed them together, and you've got this. You literally just add them together, and it works somehow.
It
So
is
yeah,
it is surprisingly like simple phase wise because it is really if you think about like waves, like how you add together waves, then adding phases just graphically it makes a lot of sense. You just
yeah,
overlay when you overlay blue with red, you just get nothing. When you overlay red with red, you get more red. So
yeah,
it's very graphically, it's mathematically nice actually.
yeah. It's very nice for like molecular orbitals. Um,
That's another thing. Today I'll have to do some geometry notes to make the phases walk, and I think I have a one idea which might actually be pretty good. I know it's very loosely not really relevant to what you were saying. I'm just afraid to step into a rabbit hole right now because I know you'll have to go soon, and I'll
oh
just
yeah, it's all right though.
Yeah, because last night, for example, we went on for way longer. The stream basically doubled for no reason. Hey, make it. How can an electron pass through node when it can't go there? I mean, does it space shift? Quantum mechanics is always the answer.
This this
I'm
is
pretty
quantum
certain it doesn't.
mechanics.
I don't think it passes. I think it's just like its probability passes, and that's like a very.
It doesn't even move. It's like the wave function kind of represents all the places it can be, and so you kind of assume it to be in all of them at once.
And none of them at once because quantum mechanics.
Yeah, and then when you look and pick out where it is, it has a probability of being in a certain location, and at the node, it has a probability of being zero there. But this is all, quantum tunneling. If the wave function goes beyond a point where the particle can't go, the particle will still go there because the wave function lets it.
Yeah, so it's basically the particle isn't really. That's so quantum mechanical though. That's such an annoying thing to explain. So you see, it's not that the electron moves there. It's more like electron is allowed to go there. That's more what it is. You see this impenetrable wall? Well, it's not really the electron going through the impenetrable wall. It's basically electron being allowed to exist on both sides of the impenetrable wall. Welcome to quantum mechanics. Hope this clears it up. Mu and physics turns into balloon animals. I don't know, I do like. I get why you like this part of chemistry, honestly, most because it is.
I just think it's really cool.
It really is. All right. This is the time to do this thing. If you wanna, by the way, mention anything else chemical related in the background, as I mentioned, I am listening. It's just that I like to do things in the foreground because, ADHD. I need to do stuff. Oh wait, I don't think that's ADHD. That's one of them. One of them disorders.
I mean, one thing I wanted to mention is that in chemistry, we don't call them by these L values or the NL value. We give them these different names here. So like DXY, DYZ, DZX, and these are all codes for the NL values basically, but we've given them these different names
because it's related like the orient. That's why that's precisely why I call the orientation, because it's related to the.
Yeah, it is the orientation basically. Especially if you look at the 2p orbitals or any of the p orbitals, you can see there's a px, a py, and a pz, and it's literally just
them
the
facing
axis
different
there.
ways.
Yeah, the axis there along. And for the d orbitals, it's a bit more complicated. It's basically just if they're between two axes, then they get one of these names, and if they're along an axis, you have a squared kind of property on it.
So the next one will be cubed. Okay,
yeah.
Wait, so is it squared or is it like just to know that it's only along that axis?
I don't know like where the name comes from perfectly, but when it says squared, it means it's along an axis. And so for this dxy x squared minus y squared, this is like it's kind of like four lobes all pointing in the x and the y axis.
I don't mean to insult chemistry, but based on all the naming conventions I've seen so far, the square doesn't fill me with confidence.
Well, it probably does come from maths. There's probably like a reasonable mathematical justification for it. But...
I mean, there is probably a justification for it. Is like the source of 90% of naming conventions.
But like it seems like a maths thing. To me, anyway.
I am curious though about the equations, the wave function equations, because
sorry.
I am really curious about the wave function equations because, like, the quantum numbers, they are actual numbers using these equations. It's not. It's not like electronegativity where it's very like, I don't want to say arbitrary, but it's basically not like electronegativity. We're just made up. It is like a very real thing electrons have, and so because that is using crazy, and the fact that it's discrete, that's still so insane. You have the fact you can have this. You have discrete numbers, basically.
Yep. I've got more rabbit holes to go down if you feel like it.
Okay, I think I'll try to do the phases. Mathematically, it should be actually pretty simple. Mathematically, I'll actually do it the exact same way it should be done. So basically, I'll have one phase, which is this. So distance node. Mathematically, it should actually make a lot of sense what I'm about to do. So we'll have the generated distance to the object. And now this one will I don't have a sound on, but as expected. Well, to be fair, I'm not really playing anything in the background, so there is a solid possibility that's a me problem. Oh, why is it like this? No, that's wrong. So wrong. Why isn't the corner? I think I know why. Okay. 0.5.
Oh, I found that slide that talks about the how we like work out the mass of the benzene molecular orbitals.
Oh, wow. That looks fun. That certainly does look like a way to do it.
Oh yeah, I'm going through all my quantum mechanics lectures and it's just all maths. It's
Okay, wanna
there's
see
there's no
something?
pictures, there's no fun.
Hold on, wanna see something really cool?
Yeah.
Okay, I'm not saying I'm awesome, but like I am pretty amazing. Look at the screen for a second, the stream.
Okay.
See these?
Yeah.
So like when you have them out of phase, basically this is what will happen, right? Like obviously not exactly, but like
Okay. Yeah. I mean, you should show the like other ends pushing away as well if you can, but
I
I
mean
know
no,
it's
this is
difficult.
actually as simple as it could be. What's really fun about this is I can switch it so that this is what both of them are positive. This is when both of them are in phase is when they are out of phase, kind of.
That's
I am.
nice.
That's
So
very
you set like a
difficult thing.
gradient, and in the middle of the
This
gradient,
is
it's just
actually as simple as
colorless.
it could be. So basically, for each point on the texture, right, I calculate the difference from this one and the distance from this one, and
Yeah.
then I hold on. Where's my pen? There we go. So for each one, I just calculate the distance from each one, and then I multiply the out of phase one by -1. Then I add them together, and then right here, and then I square it. So I do quite literally, how it's normally filled up. It's actually
Yeah.
not that impressive. I don't know why I feel so proud of it. I think about it, it's kind of obvious. Maybe it's good enough. Yeah, I'm certain it's good enough. That's kind of what's happening, right? Kind of.
You really should show like the edges like pushing away because it's not just that they're canceling out; they're actually repelling.
They are actually repelling.
Yeah, they push away from each other. So like, let me draw up a.
I did not know they actually. I've read 6 times more algebra analysis, and the two subjects are both 10 points. So yeah, big fail analysis. Don't let analysis get to you. Analysis is a huge fail. I know how much you don't like analysis, Elliot. So, I mean, if you did well on algebra, that's good, right? Okay.
This is like an exaggerated drawing, but you can see that like obviously I haven't drawn the phases here, but you can tell this is in phase, this is out of phase, and you can see the density pushes away. It doesn't just like cancel out in the middle; it literally pushes outwards away from the center.
Wait, why? That's
I
you
don't
kind
know.
of wrecked my entire understanding of the topic right now because this doesn't really make sense.
uh,
Oh no.
this is yeah. Let me try and find a thing that explains why, and then I'll tell you. But this is how it is. That's just how it goes.
Oh no.
Let me see.
Oh, oh no, no, no.
Maybe it's not that it's pushing away, but it's that as you cancel out the middle, it means that more of the density that you find is further away. Does that make sense? Because like these shapes that we define, the shapes that we show for these electron densities, they are the shapes represent when the probability of finding the electron there is above a certain threshold.
Wait, can you look on stream for a second?
Yeah.
Would it be sort of like this? Like pushing away this sort of thing? The outer face?
Um,
Because this
kind
would
of,
make sense.
yeah.
Because this would make sense, because that's just mathematically how waves work. So basically, it's not really them pushing away, only them canceling each other out, right here.
Yeah, I mean, the thing is, when I picture it pushing away, and the actual like shape of what you have left is different. But it might just be a case of, um, well, because like the shapes we represent are like when the probability is above a certain threshold. Um, it might be that as you cancel out the middle, it means that the probability that's above like I don't know 95% whatever the threshold is, um, more of that probability is further away. Does that make sense? It's kind of it's really hard to explain. Um, how do I explain it? Uh,
No, I'm not gonna lie, I really did. It kind of. I really don't get it now.
yeah, wait.
Are those electron clouds? Yes, they are electron clouds. And hi, the random space enthusiast. Where's this walking? So we have this like.
Okay, I'm on a slide. Um, we've seen this slide before, I think.
Yeah.
But what I'm kind of saying is they do cancel out, I think. But when we show this shape, it's when the probability is above a certain number. So let's say that this shape represents when the probability is above like this point on the y-axis, this line, right? So anything above here will show in this shape, anything below doesn't. And in this example here, you see the probability, it's above a certain point here. But when you cancel out this middle bit, it means that more of this left side is now above 95% of your overall
Oh, I get it.
probability.
Okay.
And so it means that this shape
Normalizing,
that we
basically.
use to represent it is
I don't
now
know.
pushed outwards.
I know how
But what you've
much.
actually done is cancelled them.
I know how much like quantum mechanics you done, but do you know normalizing? Actually, that's more
Yeah,
probability,
yeah.
I suppose. So it's basically
And I do know
normalizing.
normalizing.
Yeah. So it's basically
Yeah, I
you
guess
have
so.
less
Yeah.
area under the function, so you have to multiply it by a higher value in order to get the sum to be equal to 1.
I think so. And I mean, in this diagram, he has kind of shown what looks like less area,
Yeah,
but
so
I'm
that's
not
like, for
sure
example,
how
why
the area
the peaks
works.
on the
But yeah,
right are higher. It's because like you need to multiply it by a higher value and to get there, and because you multiply by a higher value, the values down here also get included.
yeah, I'm not entirely sure. I don't know if these are normalized. I'm not sure if he just like
I mean,
kind of
they
ignored
have to be
the
because otherwise
y-axis.
these peaks would be way smaller. Way,
Well,
way
yeah,
smaller.
yeah,
Like these peaks should be smaller than these ones.
yeah,
Kind
because
of
you're
by
looking at the
definition.
overlap, right? And wherever the blue overlaps with the red, you subtract it. So, yeah. Um, Yeah, I think this is how it works because the shape represents, I think it's 95% of the probability. And if you're like getting rid of all the probability in the middle, then more of your probability will be on the sides. And so that's why the shape, when we draw it, the shape is further away. Because you can see here quite clearly that these are like further apart than these.
Yeah, like you can't just get rid of probability without adding it somewhere else, because then you would have basically a
Yeah,
chance of
yeah,
electron not existing.
yeah. So I think that's how it works. Um, I never really thought about the whole canceling thing, but I think that this makes sense in my head. Yeah. So yeah, when we represent them, we do represent the shapes kind of pushing outwards, and so I guess we treat it like a repulsion in that sense. But yeah, it is canceling out, I think.
Okay, good. I just don't want to
Yeah,
re-script the
no,
video. That's all.
yeah.
That's all I care about.
Uh, Let me see if it mentions it anywhere. Okay, I found. Okay, if you look at um, this paragraph here, this is talking about how when you have the electrons in the middle, it keeps the nuclei close together, right? Because it's like a kind of like a glue between the nuclei, because they're both attracted to the electrons. But when we cancel out this middle bit, there's barely any electron density between the nuclei, and so the nuclei repel. So the nuclei get pushed away because there's no electrons in the middle of them to
Oh,
hold
that
them
makes
together.
sense. Okay.
So your bond length increases. Yeah, this is another thing in chemistry is that when you have a stronger bond, the bond length is shorter, and when you have a weaker bond, the bond length is bigger. On it usually, apart from some like edge cases.
Well, wait, you have to say like usually on
Yeah.
average because it's there's always
Yeah.
this one.
There's always gonna be some. Yeah.
There's always gonna be basically the water of bonding.
Yeah. I mean, even in my in this stuff we're looking at, like bonding between metals, and there's loads of weird stuff that goes on with these. This is actually kind of relevant, the spin stuff, because I
Oh,
said there's like an
spin.
S and there's an M. Yeah, there's an S and there's an MS, right?
Yeah. I remember.
And on this we've used capital S because this represents what this is the S of one atom, this is the S of another atom, and then this is the S of the whole system. And so we're showing here how we can add up these spin values. But these capital S values can be bigger than half because you've got more than one electron. And so, is there a thing that shows the electron? There is something somewhere. But you can see we've got like these higher s values, and then this is all about like coupling them together.
Wait, hold on. What
Um,
is actually? I haven't. Oh, fudge! I forgot what spin. How strong do you feel right now when it comes to going down a mild rabbit hole?
Fine, yeah.
Okay, would you mind giving me like what you did? Would you mind doing what you did yesterday for anti-bonding, except for spin right now?
Um, I mean, spin is quite straightforward. Uh, Essentially, so obviously the stuff I just showed you is like really advanced. This is like when you've got loads of electrons interacting together. Um, but what I showed you yesterday was you essentially there are technically two quantum numbers that relate to the spin, but we only really care about one of them, and so that's why we say there's four quantum numbers, even though there's actually five, because there's an s quantum number, which is the magnitude of the spin, which is always a half for one electron. So that's why we don't care about it when we're talking about one electron. But then you've got your ms, which gives the spin a vector component, and that lets it be plus half or minus half.
So ms is kind of like the unit vector of s. So we have s
Yeah,
as the magnitude, ms as the unit vector.
yeah. I think there's a. Is it in here? This is like a representation of what we're doing with spin. So obviously this is showing like capital S. This is showing more than just plus half and minus half. But if you focus on just these two, you can see that kind of it points at an angle in the z-axis, and we only have the z component, so it can be anywhere along this kind of blue circle. But what we've got the angular momentum in this z direction. And so it can either be pointing at an angle upwards or at an angle downwards, and that's our spin plus half or spin minus half. But you can see that the magnitude in the z component is always half. It's just that when we make it ms, we give it a sign. We make it pointing up or pointing down. And this diagram is showing how when we have more spins, it points more towards the z-axis. But yeah,
Okay.
you
No,
shouldn't worry about higher
think
spins.
I I think I get it. I mean, there's actually first of all, that's mathematically beautiful, absolutely phenomenal actually to think about it this way. But second of all, what I'm having really hard time wrapping my head around is actually what is spin? Because
Yeah, I mean it's angular momentum. I don't know.
I mean, yeah, precisely, right? So, but I mean, I get that. It's just that when you have more electrons, the spin of electrons of a singular. Wait, no.
Well, what we're doing is we're adding them as vectors because they are vectors. So where is it? In in this diagram, you can see we're literally just adding the vectors to get a resultant spin. And it's that
Wait, but
simple.
what
Like
is
we literally
spin
just add them.
used for actually?
Well, stuff like, for example, EPR spectroscopy, which I gave you a mini presentation on. Um, uh, that's like the first example that comes to mind for me because I did a whole thing on it. But it's kind of in this topic, it relates to the magnetism, and it's kind of just responsible for a bunch of different properties. This
Just
is this
one
is
example,
really complex.
like one example. Yeah, I don't
Well,
even have
the
to understand.
example
I
is
just
EPR spectroscopy is like
yeah, but like what exactly happens? That what exactly spin affects?
um I'm trying to think. I don't know if I should talk about this. Let me have a look at this and see if there's anything I can bring up.
Yeah, I don't even have
Well,
to
I mean, for
understand the
example,
example.
spin is responsible for magnetism. Like when the spins align, you get magnetic stuff going on.
Oh, okay. So like when the spins aligned, then wait, what? No, no. So when spin is aligned, you basically get a magnetic field.
Yeah, this is a very, very simple. Yeah,
Okay, I
yeah.
see.
I mean, spins are what cause magnetism, but here, this is like this is the EPR stuff here. And this is showing. I showed you before how you have your spin plus half and spin minus half states, and they're meant to be the same energy. But when you put a magnetic field on it, on your sample, the states change in energy because the field will stabilize one and destabilize the other because one is aligned with the field, kind of, and the other one's disaligned with the field, kind of.
Hmm.
And so that that means that this energy of the two states that are normally degenerate splits. Degenerate means same energy,
I'm
by the
having
way. I know I keep saying it, but
I'm
yeah.
having trouble
Um,
articulating exactly what confuses me. So, hold on, let me
yeah, I
just.
haven't really explained like what the
I
spin
mean,
does,
well,
I
no,
think.
there's like a very specific thing that confuses me. So it's basically like, okay, there's only one way I can think of wording it. Hold on, give me a second. I'm really trying to articulate why exactly I'm getting confused. It's basically like spin feels irrelevant. It's
I mean, when you're looking at one electron, yeah, it's pretty irrelevant. It doesn't do much. All that matters when you're looking at like individual electrons and doing the basic stuff is, that thing I showed where you have like the lines that represent the orbitals and you draw the arrow up and down and
oh,
all
I think I
that.
have a good example. I think I have a good
Yeah.
example of what I mean. Spin kind of feels like acidity. It feels like what acidity felt to me before I fully understood the thing. So it basically feels like a certain property, which, like, when I started learning about acidity, right? I was getting all those descriptions, all of those properties, all stuff like this, without actually being given like an
Like what
explanation
it
for what it
is.
is. Yes.
Okay.
So like
I
for
mean,
acidity, it's the attacking and, well, quite well, not really, but that's what basis. But you get what I mean, right?
yeah. Let me try and find something really quick because there is a slide somewhere different. I'm gonna close the screen
I
share for a
don't remember
sec.
why spin symmetry exists for spin larger than one theta. Well, hide the theta first of all. Second of all, I don't even know what spin is. Bomb me no idea what's going on. We're talking about
um,
electrons.
I I've got some good slides for my EPR experiment that because he like showed us all the theory for it. Um, it's great. This professor that showed us the EPR stuff is the same that did those like first year slides that show all the molecular orbital stuff. He's my favorite guy. Um, where is it? By lab manual. Okay. This manual's massive because it's got like all the theory and the lab stuff and the it's, yeah it's
It
got a
is a
lot.
capital M manual.
Okay. I think this is what we want. So you should imagine the electron spinning on an axis, right, like this,
Mhm.
and this is what we imagine, and this is why it's called spin, even though it's not actually spinning.
You should
And
imagine
yep,
an electron as a ball that is spinning. Yeah, it's still quantum
yeah,
mechanics. Absolutely. Yeah, trust me, it's still
yeah,
quantum mechanics. Just imagine it as a ball that's spinning.
yeah,
It's also not a ball; it's a cloud. It actually doesn't exist. It can't spin. It exists everywhere, nowhere at once. It can go through stuff, but it's a ball and it's spinning. I get it. Okay.
yeah. So you imagine it spinning, um, and because it's got a charge and it's got angular momentum, it gives it a magnetic moment.
Mhm.
So this is how spin leads to magnetism.
Oh, that actually. Okay, so magnetic moment's the reason, basically. You have like, oh,
What no, magnetic moment is the result of spin.
yeah, but like, hold on. I think I get what's confusing me. I feel like, so basically, is it like you have the magnetic moment, right? I don't know if MM is a good way to know them. Basically, magnetic moment, and we know the
Yeah.
that magnetism exists. So
Yeah.
basically, we created spin as the missing component. So like, we knew this exists, and so we added the missing thing.
Or I
So
don't
it's
know if it was used to explain magnetic moment or not.
Yeah, but
I can't confirm that,
yeah, but
that
like,
would make
is that
sense.
how it's used? Like, is spin used to justify magnetic moment? As in
Um,
the same way as like, oh, what would be a good example? In the same way as like resistance would be used to justify. No, that's not a good example.
I mean, I get what you're asking. Like you're saying the spin was made because we observed magnetic moments and we knew they had charge, and so it made sense to give them angular momentum.
Yeah, that's yes.
I don't know the answer to that.
Well, at this point, I'm
I
not
don't
even
want to like
asking if
give you an
that's why it was
answer, but
created.
yeah.
Only if like if that's why it's
Yeah,
used.
that's not the only thing it's used for, but that is like magnetism
Okay,
is most of what spin is.
okay. So basically, it's magnetism and the additional other stuffs.
Yeah,
Okay,
and I
so
mean if you
spin
look
is just for
here,
magnetism. Name spin is really not great. Then,
well,
but
it makes
like,
sense if you think of it spinning on an axis and
yeah,
it's got
but
angular
like,
momentum, and that axis, the axis is important as well because that's here's this diagram. This is the same diagram from before, but with just plus and minus half.
yeah,
So
but
this
like
is more
,
relevant.
if you have to say that, like, if you think of this probability density cloud as spinning along an axis, you kind of lose me. I know that's
Yeah.
it's a like a good way to graphically explain it. I'm just gonna add it to the list of like conventions which upset me. The very long list. Okay, so
Yeah, I mean,
spin
I
is
don't know where the
basically
spin
like
emerges from.
so
It probably emerges from quantum mechanics, to be honest.
yeah, so spin would be like the angular momentum of electrons, which is used for magnetism, which is used
Yeah,
to
you need to
describe
be careful
magnetism.
because there
Okay.
is also like there is also the whole ML stuff, which is angular momentum as well. But that's I think that's the angular momentum of orbitals. I'm not entirely sure. It's like a different angular momentum. We've been taught them like separately, and they've never overlapped that much. But the ML is like a form of angular momentum in a way. Like it represents angular momentum.
Spin was introduced because there were special lines which were very close together but slightly different, meaning they needed a fourth quantum number to explain it. Yeah, but they called it spin for some reason. And in this case, it seems like the reason why it's called spin is because it's because physically it's very similar to the way angular momentum would behave. That's what it seems like.
Yeah,
Okay.
yeah. I think so. I don't know because I've been taught like how to think of spin and how to use it, but not exactly where it comes from. Which is most of chemistry is we get this stuff from physics and we use it,
We
but we
don't
don't
question the
care about
physics.
the physics. Yeah.
Just trust the physicist.
Yeah.
And physicists actually are doing the same thing except with math. Like they get math
Yeah.
tools.
And
And
I'm quite happy doing that
mathematicians,
because I don't want to look at the
yeah,
physics.
and mathematicians actually do the same thing except they get all of their maths from like a really high guy who's just like really stoned. And that's a circle of, and chemists create the drugs, and that's a circle of life for you. Right, I think I get it. Okay, cool.
Yeah.
Now I'm
And so
at
this is just a demonstration of this like you can see this axis. So this is our spin axis, right? This red or this blue. And it's when we say it's spin plus half, that's our ms value. It's this vector points anywhere along this circle. And it has to be this point, this like circle here, not a circle down here or something, because that's our magnitude.
so basically, when the reason why it has a negative half and a positive half only for one electron is because when you add another electron, you would basically think of it as like adding two more arrows. Once again,
Yeah,
with
I think you just
magnitude,
start adding the
this
arrows together pretty much. Yeah.
yeah, and then okay, okay, okay.
Yeah, I mean if you go on this this is literally this whole thing. This is about coupling spins of this vector coupling of spins of
Yeah,
this in this case it's copper ions,
actually,
but
walking with
you
spins
literally
seems
yeah.
really like mild and tame in comparison to
Yeah,
like
no, this is
considering
really
that
straightforward. This
yeah,
is literally you add them and you subtract an integer until you get to the negative,
you
until you get
need
to
to
zero,
tell
and
me
that's it.
that like when it comes to quantum mechanics, you just throw in a random imaginary number for the funsies. But when you're working with something which is literally called a quantum number, you just add them together. Like with there's no integrals,
Yeah, no,
there's no
I mean,
partial
for this,
derivatives, no
what we do is
limits.
we take the two spins, and we want to couple them, and it's going to give us some resultant possible spin values. And we literally just add them together for our maximum, and then we subtract one and subtract one again, and you keep doing that until we get to the difference, one spin minus the other. And so in this example of coupling 2 with 3/2 or 1.5, you get these, and that's it. These are our spin values for the two combined. That's it. It's really, really easy. But then it goes into stuff like ferromagnetic and antiferromagnetic, and lining up the energy levels in different orders based on the ligand you have, because there's like you'll like this. We have this overlap with these ligands in between the metals, and the spins have to align across the ligand, because you can't have two of the same spin in an orbital. And so it couples these two spins of these two metals, even though the metals aren't actually bonded to each other. And you get some fun stuff going on here. I find this pretty cool. And here's our friend zero net overlap on here. So
I remember this one.
yeah.
There we go.
So this is like a really advanced application of some of the stuff that we've looked at,
Yeah, it really seems
which
like
I think is quite cool.
deeper you go in chemistry is just the same things, except it feels like, okay, what it feels like in chemistry is like you start with these basic rules, and the rules don't change. Only as you go on, it feels like you're basically being questioned by a professor. You're constantly getting the answers right, and professor really wants you to prove it wrong, and so it just gives you more and more insane things to do. Like
Yeah, I mean a lot of
let's
stuff
throw a ligand
is...
in the middle. Okay, what
Yeah,
if they're
I mean,
both at the same time?
that's the thing. Oh, where is it? There's yeah, this exactly. A lot of this stuff is they make an observation, and then they're like, well, this doesn't make sense with our model, and so how do we move the rules around to explain this observation? And that's literally it. So it's like stuff like this. They discovered this, and it didn't make sense. And then they did some X-ray stuff. They found this structure which showed a weird bond length in here, and it's like it's all just like extra stuff that you like discover, and then you have to explain it in terms of the theory we have, or add to the theory.
Yeah, it's basically the difference between magic and science, right? Like you can't just accept.
Yeah, I mean,
that something
you get this
exists.
measurement, and you're like, this is magic, until you can explain with science.
Yeah, you can't just, well, it wouldn't be scientific to just assume that it just happens. There has to be an explanation, and so we just keep going for like a couple of decades,
Oh,
until
this is a great example here. This was the first quadruple bond ever discovered. So
that's really-
imagine the like surprise when they get this data, and they're like, what is going on here? Yeah, it's fun stuff.
It really
Let me
is.
see
And
if it shows the quadruple bond anywhere. It might be in here.
also, it's like most
Here's
of
our
these are so
quadruple bond.
specific. Wait, can
Yeah,
you
I mean,
go back
they-
to the
yeah.
Proust one for a second?
Yeah.
So it's the quadruple bond in
Oh, in where is it?
it's quadruple bond
Yeah,
in
in this.
cesium. Where what's Re? That's
Is it rhenium? I actually can't remember.
oh, it is an atom. Okay, I was just asking
Oh, no,
if
yeah,
it's
yeah,
like
it
if it's
is
an
an
atom,
atom.
because
I forget my...
table
Yeah, it is
of
rhenium.
how
Okay,
my
I was
beloved
just checking.
chemistry website. It's rhenium, yeah. So basically, it's a quadruple bond between cesium, rhenium, and four chlorines.
No, the quadruple bond is between these two rhenium atoms.
Yeah, but like you need the wait, hold on. Am I getting this right? You need
Let me
cesium
show you,
and-
because this shows the quadruple bond here. This is the structure that we have.
Yeah, but you need the four chlorines in order for this to actually form a quadruple bond. If you throw in just two rhenium atoms, they're not gonna bond.
Yeah, no, they won't just bond by themselves.
Yeah, so like it's so specific.
Yeah.
Yeah, we added these four chlorines together, and all of a sudden it behaves in a completely different way. and then
Yeah.
decays. Well,
I mean that's how chemistry works. You add something and then
that's
it
really
changes it.
actually cool. I kind of lost my motivation for doing calculus and stuff. I mean, what made you lose your motivation? Because there are certain things which I honestly get. Why do you would lose motivation after them? Calculus. Oh, it's really still so wild that right now, when it comes to ptable.com, I can just go to electrons and like all makes sense.
Yeah.
Like I can just,
I was so surprised that you didn't know what the arrows meant.
I don't know.
And they've
Antibody, never
actually
heard them.
lined them up with the relative energies as well, because you can see they haven't lined up like the 3D with the 3p. They've kind of put it above 4s, which makes sense because
Yeah,
the 4s orbital is actually lower energy than the 3D orbital, even though it's a higher n.
actually, oh my goodness, it clicked. Finally, took me a while. Well, now the isotopes
Oh,
will
and they
be
even
next
show
thing.
the nodes on here. I forgot. They even show the nodes
Yeah.
in those orbital diagrams. Yeah. So yeah, those are yeah.
I just with every passing day, I just love it more and more. Well, now the only thing left to conquer will be the isotopes. And like decay
Oh,
and stuff.
isotopes are fine. Isotopes are very easy.
I don't know exactly how, because isotopes.
Well, the isotopes are just when you have a different number of neutrons.
I mean, yeah,
That's
but you
literally
know,
just it.
it's never that simple. That's kind of like saying, oh yeah, electron clouds. When you have more electrons, it changes, right?
I guess, yeah.
Yeah. So like, I get the theory behind. First, okay, and also one more thing is I would like to just take a second to appreciate the amazing web design for this,
Yeah, it's actually really
and the
nice.
commitment on actually adding all of them.
Yeah,
Like
I
just in
love the
case,
decay thing as well, where they showed like the alpha and
yeah,
beta
they show you the
decay and
type
all of
of
that.
decay. It's also just the dedication. I just love this site so much. It's phenomenal. But like when it comes to this, because I know that like when it comes to decay, okay, I kind of get decays because
Mhm.
no, it's actually pretty self-explanatory, right? Well, wait, alpha I think was with atomic particles, beta was with
Alpha's like
subatomic.
a what is it? Is it a helium nucleus that it releases for alpha, and then beta is an electron that it's giving away.
Yeah, I always just thought of it as like alpha is atomic particles, beta is subatomic, and then gamma is elementary.
Uh,
Because that's kind of what's happening.
I've always thought alpha it gives away a nucleus, which I think is always a helium nucleus. Beta it gives away an
Yeah, I
electron,
just
and
didn't do enough research to actually claim that's always a helium nucleus because and that's why I took the safe approach of just saying yeah, it's just an atomic particle.
yeah, I'm pretty sure it's always helium for alpha decay, and then the other one is just the gamma is just literally just light.
Yeah,
It just
gamma is
gives
just
away light.
photons. Oh yeah, it actually makes sense as electron, right? Because then you have a separate one for positron. That
Yeah,
can make sense.
that's exactly why they've.
And it's
It's a lot
spontaneous.
nicer that they've called it positron
Oh
emission,
my!
but they haven't called the first one electron
Oh
emission.
holy crap!
Oh, does it say helium?
Nuclear
Or what
physics.
nucleus?
Wait, hold on.
That looks like two protons and two neutrons to me.
Decays in different atomic nucleus with a mass number is reduced by 4. So
Helium
yeah, 4.
nucleus.
So it
Yeah.
has to be helium. Atomic number, yeah. If mass number reduced by 4 and atomic number reduced by 2, that has to be helium.
Yeah.
Speaking of, I'm doing homework on just that. Does anyone have a formula to calculate the energy released by gamma decay? I can't find it anywhere. I haven't gotten to decays. I haven't gotten to isotopes at all.
I mean, a photon energy can be like a wavelength of a photon or a frequency can be translated directly into energy.
Oh, you need that because that's actually pretty simple. That's HF if I remember correctly.
Yeah. So I don't know if you know
I'm such a fucking
the
nerd.
photon, then you can just work out the energy because it's just the energy of the photon.
It's almost as if energy is like doesn't disappear or something. They should make that into a law.
Oh yeah, if you look here, these are the delta bonds, and this is literally the first time I'd ever seen a delta bond was like a couple months ago in this lecture, and so it's literally just these d orbitals. Like you can see, there's barely any overlap, and so this energy difference here is really small, but they have actually shown it. And then with this ligand, it changes. But this is in the metal. And so I thought this was cool because we'd never seen delta bonds, and you like brought it up in your stream because you like you were checking the rule about S and P.
Yeah, on video. I mean, I'm not smart. Okay, it takes me. I need some thinking time before I actually figure out anything. By the way, random
Yeah.
space enthusiast, could you describe a problem a bit more in detail to us? Because then maybe we could figure something out.
Oh, you don't have the photon. Yeah, if you give us the problem, I can probably. I mean, it is physics. Like,
So, we can figure it out.
radiation is physics. Because in chemistry, we care about the electrons, not the not the nuclei.
I really do want to do something like practical with radiation, because it sounds like a lot of fun. But it's
Oh,
expensive.
if you look at this, this is like you can understand what this means now, can't you?
Yeah, I can.
you look
It's
at
actually
history.
quite incredible. So you can basically.
And so this is our bond order, right? Because I said bond order is like it's a number of bonding electrons minus number of anti-bonding electrons, but then you divide it by 2.
Oh yeah, and then quadruple bond actually requires. Wait a second. Oh my
Yeah,
goodness.
that's
So
why
like,
it's 8.
so when you bond together, hold on. Was it nitrogen? I think it makes a triple bond. I think it was nitrogen.
Yeah,
And so that's why it makes a
Yeah.
sigma and 2 pi bonds.
yeah,
And that's why a single bond will basically be a sigma and a pi, and a triple bond will be a sigma and 2 pi's.
yeah.
And then
Because a
quadruple will
sigma
be-
bond is always more stable than a pi bond.
And then you can
Well,
basically
I say
have
always. I haven't seen any examples where it isn't. But yeah.
You could have an octuple bond with a pi bond. You could have an octuple. You would need an octuple
it would
to form a
be.
pi bond, which was
Well, I don't even know because you'd probably
Wait.
start adding more d orbitals and doing more delta bonds before you get to the other one. Because
bond.
when you do pi bonds, you can do 2 pi bonds.
Yeah. So that's why I said octuple,
so,
right?
yeah.
Because I think. If I'm-
Yeah, I'm not sure.
Hold on, pi bonds.
I don't know.
Has a
I don't-
Wikipedia page.
Probably
which is-
hasn't even been
like
probably
such
hasn't
a-
even been studied.
Listen, I mean, we have as a research idea, right? Try to make a phi bond. Technically
Oh, God,
possible.
that would be such. It
would
would be
be-
all maths for the research.
I mean, on what would you even use to make a phi bond? Like, how many bonding
Well,
electrons
they
would
said
you
in
need?
that third paragraph that they tried doing it with uranium.
Yeah. Latest accounted for spin orbit interactions found that bonding was only of 4th order. Experimental
quadruple
evidence
bond.
for free bonding between thorium atom and cyclooctane train in taurucine. That's
Yeah, you can tell
So
what that is. You
specific.
can work that out with your IU pack.
yeah, but
Train.
no. Well, nothing is like how specific that is. It's no longer like you have these 2 atoms bonding. No. You have these 2 atoms bonding in this precise molecule. Otherwise, it won't work.
Yeah, I mean, a lot of the time it's like the theory leads them towards those kinds of molecules. They don't just like encounter them randomly. They're not just making random
Oh
molecules.
yeah, I
and
know,
like,
but
oh,
it's
this
just it's just so funny because like
yeah.
you have to account for the fact that all the atoms in the molecule also interact with the electron cloud, right, in a more complex way. So you basically have atoms like pulling on the electron. Why am I explaining to you? You know this. Let's pretend I'm explaining to everyone watching. So basically, when you have atoms in the molecule, then hold on, I think I could even come up with an example if I retried, but I'm certain if I describe it then. All right. So basically, if you have like 3 atoms, which is like atom 1, let's call it A, atom 2, let's call it B, and let's call it C. You have 3 atoms. When these 2 bond together, then the atom A is actually pulling electrons away from B, and this is going to affect the bond between B and C. And what I found fascinating is that for a phi bond, for example, you do need this precise force. Actually, I don't know if I should call it a force. You need this precise like environment for the electron cloud to actually have a chance at forming a phi bond. That's what I just find it really, really interesting. the uranium is so bizarre. It doesn't even have a Wikipedia article. I mean, but honestly, that sounds like quite a fun challenge. Make a phi bond.
Yeah, it would be kind of cool, wouldn't it?
Do you think that there's any research on it? I mean, last papers from
They're probably. Let me have a look, actually.
create of the bond.
I'm going in Google Scholar.
Oh yeah, Google Scholar. That's I don't actually use that. I'm not a scholar. I just Google the take a look. Hey, hello. Wikipedia becomes unreliable at this stage after undergrad level chemistry. Doesn't really. It really doesn't.
I use Wikipedia to find sources rather
Yeah,
than
like-
actually get information. Because I'll go to a Wikipedia page and it will list some sources, and then I go and read those. I don't.
Yeah,
I don't
because I
read
mean, obviously,
Wikipedia.
it won't just copy and paste the entire source, obviously, but it doesn't really become unreliable. Unreliable suggests that they will give you fake info or something like that. Not really. Obviously, you won't get as much info as from the source. That's why the sources are linked.
Yeah,
And also
I don't know.
because of
I tend to just not trust the Wikipedia stuff, and instead I just like. I
Oh, I do.
only use it to find sources.
I have a friend who's like a Wikipedia editor, and after hearing
Okay.
the stories he told me about, like just how difficult it is to do anything on Wikipedia. Because what you have to understand
Yeah.
is like if you want to edit an article on Wikipedia, there are thousands or tens of thousands of angry nerds out there which will actively fight against you. Which want to prove you wrong. So like in order, if you actually want to edit an article on Wikipedia, good luck. And also your accounts and also accounts on Wikipedia are like bound to IP addresses, and because of that, if you basically want to troll an article on Wikipedia, then that's fine, but they're gonna have your IP address after that.
Yeah.
So that's why it's actually really difficult to spread fake info on Wikipedia. Actually, pretty impressive.
I found a paper that mentions phi bond character. And when we say character in chemistry, it means it's partially doing that thing, but it's not fully doing it, basically. So, because there's
Okay,
like
so it's
mixing
like
of
a
orbitals and stuff.
Fake bond.
I mean, I can send you this is the paper.
It's like a pretender. There's no joke I could make.
I guess it's like when we say something has like character of a different bond, what we mean is it's the bonds or not bond orbitals. Sorry, the orbitals are like mixing, and so it means it has a slight mixing of that orbital in question. So it means in this case, I guess, that they have this like they have some really weird molecular orbitals going on, and one of those molecular orbitals has a slight mixing of a phi bond orbital. But I don't know. I don't know if that's exactly what this
it's not
paper is.
letting-
I skimmed it and looked at the phi bond.
It's not letting me.
Does it not let you access it?
404, yeah.
Oh wait. Oh, I think I gave you the wrong link. There you go. That might be it.
Oh, there we go. Treason. Yeah, it's always so specific. I'm just amazed by that.
You know,
why.
it links to another paper actually. Let me have a look at that.
I don't know. I just feel like making a people would be cool YouTube video, and I just maybe in the future.
Cool YouTube video. You gotta do years and years of research for that YouTube
I
video.
mean, can you imagine the
Actual
content though?
lab
Like,
work.
yeah, but like think of the views.
Think of the views.
would have, like,
I mean, that's what I
10,000
should do.
views.
For my research, I should just make YouTube videos on them.
I mean,
Or I can just
honestly,
give you the research and then you do YouTube videos.
I mean, yeah, but I mean, honestly, can you imagine though, like having? But I mean, I feel like it would be a pretty beautiful symbiotic relationship because you would basically, Well, it wouldn't really be. It would be more like parasitic, like where I make a video, and you get, well, we've been more parasitic. But the point is, don't mind that, okay? Just don't focus on that. Just focus on the founders, right? So where I would make a YouTube video, and I'd be like, hey, this is actually the only video on YouTube which covers this. And
Yeah.
as a deal, you get like, I don't know, I like thank you or something. Yeah, we'll figure it out later.
I think the issue is that research nowadays is like not individual. It's all teams of people.
Yeah, but that's obvious
And
because,
so, like,
well, it's so specific. You can't just do it by yourself.
Yeah.
I mean,
and
you
so
could
like the
do it.
research I'm doing for my project is like it is like an individual project, but it's all connected to this research that my professor's group has been doing for years.
Yeah, but I mean, it's
And
not
so,
that
yeah.
surprising. It's like the same reason for why, I don't know, corporations have multiple people. It's not just a single person doing everything.
Yeah. I just mean there might be some like licensing issues with like making a video and stuff
Oh
that's
no, I didn't
part of
think
the
of that.
team instead of just mine, you know?
Yeah, but yeah, we could ask nicely, right? You could ask
It
for
would be
us.
yeah, what would make sense is if after it's published, we then do the video. So
Oh,
wait a couple years, I guess.
I could actually make the video while you're still working on it, and then
Oh,
publish the
okay.
video right on
Yeah,
the published day.
when
That would
it's
be,
published.
yeah.
Yeah. That's a long way away though.
I don't know. It's still
Thing is, I'd be
cool.
doxing myself as well because my name would be on the paper.
Okay, like, well, I feel like, listen,
Well,
that's
it would be a
actually
lot
one
of
thing.
names, but yeah.
That's actually one thing I
I
don't
think
really. I should make clear. Like, doxing yourself is not that serious. I know, like, from
well, I
my
mean, it
perspective,
depends.
it's it may seem a bit weird, like, a guy who's literally hiding everything about himself, saying that doxing isn't that serious. It seems a bit hypocritical, but if you think about it, you will at some point in the future, in the near future probably, exist as a public person, right? You'll be a researcher,
Yeah.
and then, doxing would be a problem if you would be associated with something bad. And honestly, based on the videos on my channel, I completely get it. All right, I get that. Like, I get why some people wouldn't want to have their names pinned to it. I get that. But like, just good press is good. Saying that fame, the kind of fame doesn't matter. I don't agree with that. But like, having good press, I would say that's pretty decent.
Well, it depends. It's more a case of like I prefer my like online identity to be like
That is
separate
also
to
fair.
my IRL one. And actually, because I used to be like a staff member for a really large Minecraft server.
Yeah.
That was like thousands of people knew me, and so I like it would have been annoying for people to then just find my IRL identity and then start like calling me by my real name. That would be really weird. And someone did like dox me at some point, but
Yeah.
it was like they did it as they didn't really care. So they like tried to scare me, and I was like whatever, and then they just stopped. So that was
because
lucky because they didn't have a reason to because I didn't do anything.
Yeah,
But
but like for
yeah.
that is actually the best response to doxing you could possibly have, because if someone doxes you, that's what I find funny. First of all, I just want to say that we have Lamppost in the chat who quite literally dox two people on streams casually. So please don't dox us. But second, if someone was to actually dox me, and they would be like, "Oh yeah, I know where you live" or something, I would just ask like, "So what? Are you playing in a pipe bomb or something?" I don't think so. That would be pretty expensive of you. They would actually cost you quite a lot of money. You want to publish the info? I mean, go for it. I already said like a lot of traps. I'm really proud of those. Where like there are, so far I think 11 different.
Oh well, like
names.
emails with fake names and things where someone's gonna find the email and start like.
There are 11 public names you can link me to right now, because it's a hobby. Okay, everyone needs a hobby. That's my hobby. Like the most obvious one, which I mean I can just right now, right? It's the GitHub one. Well, like on GitHub, if you go to sub to make it, which is users, there we go. You have like a name right here, and I actually had some people addressing me by this name, and every single time I like try to move the topic away. I try to pretend that like oh wait, you're not supposed to know this. Every single time
Yeah. Oh, they found me.
yeah, every single time I basically try to ignore it. I'm acting as if I'm really nervous because I just think it's really funny. That's only one
Yeah.
of them, but that's like the most obvious one, and I just like it. A little bit of trolling, a bit of harmless trolling.
Bit of trolling. I mean, the way I got doxxed before was because of one mistake I made when I was 11. I like signed up on a website
Oh
using
damn.
my IRL name email, but it linked it to like an account name I used uh that was like my related to my like Minecraft stuff. And so someone found that from some data breach because these websites when you sign up with your email, every now and then one of those websites gets a data breach and all those emails end up on a list, right?
Yeah.
And so someone found it and found the IRL name in like what 2019 or something, which was like a full like 7 years after after it actually happened,
Yeah.
which is insane. Like to make a mistake when you're 11 and then when you're like 18 years old, someone like catches up on it. It's crazy.
Theft, I just say some
But
guy.
it wasn't that bad. Like someone just tried to scare me with it, and that was whatever. Like
Theft.
they didn't. There was nothing they could do with the name
Yeah,
in the
precisely
end, but
right.
it
With
was still like
doxing,
scary.
most of the time there's absolutely
Yeah.
nothing you can do. Theft, I
Yeah,
just
and
said
there
like,
was some guy that like, so these Minecraft servers, right?
yep.
When you join a Minecraft server, the owner of the server can like see your IP address, right, and connect it to your
Well,
account.
unless you use a VPN, but that's it.
Well, yeah.
This live stream has been sponsored by blank VPN. Blank VPN. If some VPN would like to sponsor me, I'm more than glad to do it. I haven't actually revealed which VPN I use because that actually depends on who's gonna pay me for it. That depends who wants to sponsor me. That's when I'll reveal which VPN I use.
But these servers, so obviously some of them store IP data, and then some of them had leaks where the IP data would get released. And so there was this website where you could look up Minecraft usernames, and it would give you like IP addresses and stuff
Oh, I don't like that.
from data leaks. And so some guy like looked up my name on it and found an IP that I had from like 5 years ago, and he came up to me and he started telling me this town name, which was like near my location, but it wasn't even the same town, because the thing with IPs is they're not that accurate. That it depends on the IP, but most of the area, and that's it. They don't go that detailed. And so he was like telling me he was trying to scare me with this town, and I was in my head thinking like, oh, this is like 2 towns away. What's he on about? But for the Minecraft stuff I did, a lot of it was tracking IP addresses for like banning cheaters and stuff. Like they would log on different accounts, but they'd all be under the same IP, and so I could track them through the IP between different logins. And then they'd like restart their router or something, but the location data on the IP would be the same, even though the IP is different. And so I would be like tracking these people through these IP addresses and banning them because they'd be cheating, and that was fun.
Basically, just I mean that is something people don't think about all that often. Like IP addresses are public. Like it's not
Yeah,
like a secret. Unless you use a VPN, someone on the internet will know your IP address. And if you do
yeah,
use a VPN, then your VPN provider will know your IP address. There's no going. It is
yeah,
impossible to just like not use an IP address, because the whole point is the packets from the internet go back to your computer because they know your IP address.
yeah.
And so that's something that people don't really often don't think about when they are just trolling things online, either on Minecraft servers or Wikipedia or whatever. Like they know where you're from. They have to, well, at least where your machine is from, like on the web. They have to know because otherwise you wouldn't be able to interact with anything.
Yeah.
It's like sharing your public key. Always remember, kids, share your private keys online because sharing is caring. So speaking of my debit card number, the average density of Earth is greater than the average density of the Sun. The average density of Earth is about 5.5 grams per cubic. Maybe our average density of the Sun. Is that true? That's a
I don't
wild
know.
fact, actually. If you are putting a chemical solvents
I
in
mean, I
last...
guess it makes sense because the what is it? Is it fusion or fission? I always forget. It's making a nuclei, so it's fusion. That the energy of the stuff going on in the sun is like pushing out on it and is balancing the gravity against the I think the fusion energy. It's like releasing energy and pushing it outwards.
Wait, did
Fission and fusion. Okay, yeah, yeah.
so Matt apparently is the one who added. I think mother means hexane and methamphetamine, or heroin and methamphetamine. I'm not certain. But yeah, two precursor chemical solvents. Wait, hold on. Precursor chemicals, precursor some illicit drugs. Wait a second. Let me see something. I've been lied to.
About what?
There's no sulfuric acid here, unless I'm wrong. Never
Well, it
mind.
might not be given as a
there is
precursor chemical. 'Cause
sulfuric
it's,
acid. Never mind.
Yeah, okay.
Yeah, I was just wondering. I literally today I was just wondering why I can't sell sulfuric acid.
Oh, so this is why you
And
made
I-
sulfuric acid. I see, I
No, no. What would I even
see.
like?
It all makes sense now. It all
What
makes sense.
what do I even like make of sulfuric acid? There's like there isn't like anything interesting you can make with sulfuric acid. Like come on, mate. What do I even like? You know, hold on. Oh, where is it? Like, wait, did I? What do I even make of sulfuric acid? Okay, there isn't even anything interesting I can make with sulfuric acid. Tune in next week when we'll be making allyl benzene.
Yeah, the next experimental video.
Actually, how would you make allyl benzene? Just out of curiosity.
Oh, I don't know. I suck at organic synthesis.
Because I have benzene.
It's like this whole part of organic chemistry is like retrosynthesis, where you have to look at like a product molecule and you have to break it down into all these different possible reactions you can use to get there. And I hate it because I can't remember the reactions. It's like my worst part of chemistry because it's like you have to know like I don't know 50 reactions in your head and then look at a molecule and be like, oh yeah, I can make it if I do this reaction, then this one, then this one, then this one. And it's like, what's the point, man? Like, I hate that. I hate it so much.
I mean, I kind of like it because, well, on one hand, I also hate memorizing. So yeah, this is a huge loss for me. But on the other hand, all of the reaction when it comes to the reactions in organic chemistry, it just feels like alchemy because like you always have a lot of steps. So you know when it goes to the low level, so like quantum chemistry experiments, right? Most of the time it's just a single step. It's an extremely complex, extremely difficult, and extremely intricate step, but most of the time it's just one. When it comes to organic chemistry, though, even making like the simplest things requires you to go through 7 different chemicals. Wait,
Let me see if I can show you my my research projects, the reactions, because it's like multiple steps to get there, and it's actually kind of cool. I think the file's got my name all over it, so I need to like
allyl benzene has
take bits out.
nothing. There's nothing about allyl benzene. 1984, literally 1984. That's the big government crashing down the free market right there, telling us what we can and can't synthesize. Reaction with application, allylation. Attachment of allyl group to a substrate, usually another organic compound. With allyl chloride. Wait, can I actually go into this rabbit hole on stream? Because the two possibilities.
Sure. It's like organic synthesis, but sure.
Yeah, but because two possibilities are either A, I fail and won't figure out how to attach an allyl group to benzene, or B, I will succeed and I will just publicly share information on how to attach an allyl group to benzene, something which even the Wikipedia is scared to show. I don't think there is a way for me to win this situation. You can make nitrogen. I mean, there's a lot of things I can make with sulfuric acid. That's why I'm making so much of it. To be fair, I just want to clarify, I wouldn't make amphetamines because that's illegal, and illegal means bad. And so I wouldn't break the law. I would never. So like, so I just want to make this public statement that I haven't made amphetamines, and I'm not making sulfuric acid to make amphetamines. So like, you know, just a public statement, because That would be breaking the law.
That sounds exactly what someone who's making amphetamine.
What? No, it's what? Flame. What are you even talking? That's insane. The flame. I feel like flame. That's crazy. What? Do you have like weren't you like looking up something else? Anything change topic? The weather's been crazy.
Yeah, I'm trying to find my. I'm taking screenshots of my my research project because it's got like loads of different synthetic steps.
Mud Studio just said, I'm pretty sure you can make allylbenzene with allylbromine, Lewis acid, and benzene. Cool.
Probably, yeah.
We're just publicly sharing step by step how to make amphetamines. To be fair, it's amphetamines, not methamphetamines. So, it's only kind of legal. Here's allylation. How does it work? Can we affect regard addition? Attachment of alkyl substrate usually an organic compound. Allylation involves the reaction of carbanium with allyl chloride. Ooh, wait. Only one source. Conjugate base of the carbon acid. Okay, so it's...
Okay, I've sent you like all these pictures, all these screenshots from my the project I'm doing, and these are like all these different steps.
Can I show it on...
Yeah, yeah.
Okay.
So it's like,
Yeah.
do you remember I showed you the click reaction
Yes.
where it's like an alkyne plus an azide?
Yes.
Or, yeah, yeah. And so what we do is in this first step we stick an alkyne on it, which is with this iodine. We just substitute it basically. Stick an alkyne on it, and then we do this cobalt complex with the alkyne ligand. And so you can see then we end up with this like this cobalt thing, which has got these two alkyne ligands on it. And then what we do is we separately make a nanoparticle, so that red circle is a nanoparticle. Oh no, sorry, that's a fluorescent thing. We make a fluorescent particle, a fluorescent molecule, sorry, with this alkyne attached. And then we make a bridge with the azide. So we add this, like, you can see in that B image. Yeah. So that's like a bridge that will bond to both alkynes. And so it attaches the fluorescent bit to the ligand through the bridge, doing click chemistry. And then we have that whole complex, which it's massive. When you look at it, it's loads.
I mean, the thing
then,
which strikes
then we
most
see what
is
it
that
does in cells.
it's not really massive. The thing that strikes me most is the fact like how complex it is. You have
Yeah.
so let's take it step by step. Kind of obvious at this point. You have these oriented a different way, but that's like obvious. Then you have this, which if I do remember correctly, oh, never mind, I forgot the name. I know what it is. I forgot the name. This is not oscillation. It was. The point is, it's basically the bonds. You get what I mean. Then you have this, which I honestly never seen this notation.
Oh, what it means is we have 6 carbons in a chain there. So it's like instead of drawing a whole 6 carbon chain, we've just condensed it down because it would take up a lot of space.
These nitrogens also look fun. That's
the result of the click chemistry.
This looks so complex.
It's not that much when you like break it down. The most complex bit is the ligands, which I don't really know how they work, but that's what her research has done. She's like researched and found that these ligands on this cobalt complex kill fungal cells, and so it's like okay, let's stick some stuff on it and see what the complex does in the cells.
By the way, I just want to respond to like Ash said, every Breaking Bad enthusiast who has done enough research can make Beth. I would just like to mention that, like, when it comes to metamine, I think, if I do remember correctly, on Wikipedia, there was like an article which just shows you the reaction in Breaking Bad for making meth. And it's labeled.
I've seen it before, yeah.
Yeah, it's also labeled like, you know, the reaction from Breaking Bad. It's like the research and how to. It's just annoying because
Well, the
the
thing is that,
information is
like,
out there. It's just the government that's keeping all the fun stuff from us.
yeah, the government knows what the common synthetic routes are, and so they
Yeah.
limit like anything that would be involved in the synthesis.
So annoying. Just
Or
let
like if
people
you
make
buy
meth.
certain equipment, you get flagged and you get put on like a list, even if the equipment's like for actual proper use for something else. If it's some equipment that relates to like meth synthesis or something, you get put on a list and the
Which is-
government like comes and checks you out.
Which is annoying because, like, if you go 4 step back, that could include anything. Like 3
Yeah.
or 4 steps back, that could be any chemical.
Yeah, I mean, there's a lot of stuff that's limited just because it's related to
sulfuric acid,
that
for
kind of
goodness
stuff.
sake. It's just, I know this is not a chemical topic, but like that's one thing which I just find really upsetting, because I don't get arguments against making meth. Honestly, like I don't get why you would want to limit that. No, for real.
What do you
I'm
mean?
not joking right now. I really
What
don't
do you
get
mean?
because like so when it comes to making meth, or I get why you would want to limit people from making explosives, for example, right? You don't want them to blow up other people. But for making meth, it really feels like to me, like, why do we limit people from making amphetamines, but we don't limit people from making alcohol? You don't have the same limitations for alcohol.
Well, that's the case of like alcohol is normalized. I feel like I do kind of
That's the
feel
issue,
like
right?
if alcohol was like discovered like today
It
as
would be
a
illegal.
recreational thing, it wouldn't be
Yeah.
legal.
And that's what's so
I feel
insane.
like.
Fortunately, in Europe, well, you live in the superposition of Europe, but fortunately in Europe, it's going the same in the good direction. Well, like more and more things are getting legalized. But in America, it's terrifying. They have the whole war on drugs going on, and drugs are
America
winning.
recently, so you know you were talking about like banning precursors, right?
Yeah.
America recently banned dichloromethane. I think. I think they said it's like okay for like research use, but the price is still going to go up.
Which
And
is,
dichloromethane is like a really common solvent. Like I use DCM
it's
all the time.
correct me if I'm wrong, but
in the lab.
wait, dichloromethane, that's 6 atoms, by the way. And I know that like size of a molecule is not exactly related, but how should I word this? Basically, the smaller molecules you ban, the more difficult.
It's not 6 atoms, it's 4 atoms, by the way.
It's
'Cause
4 atoms?
It's the
Oh,
methane that you
dichloro.
substitute two of the hydrogens.
Oh, I see. Yeah. So it's for. Oh, that's
Yeah.
even worse actually. Because basically, the smaller the atom, like, the closer you get to banning individual atoms. And so,
I mean, yeah.
and in this case, the problem is that when it comes to the really small ones, if you start banning those, at some point, even if you want to create some sort of larger molecule, you just won't be able to, because everything gets used to make drugs, for goodness sake. You can buy gasoline without the license.
DCM stuff.
I'm
I
upset.
think the DCM stuff was because it was used in like paint and other things, and so they put a ban on it to stop people from like using it for all these normal uses because it's dangerous. Like it's got a load of hazards, especially the fumes.
Yeah, I think
But the consequence is that it's used in loads of research, and so even though they're not technically banning it for research, I think the price will go up loads for anyone doing it for research because it's going to be restricted.
which is always that's so silly, in my opinion. I just don't like the fact that, like, you know, some things are considered, because I genuinely cannot stress this point enough. I know it's weird. I know it's a weird point to make, but I really don't get a single argument for why meth should be like illegal.
Well,
I get why
think
it
it's
should
just
be
the destructive
regulated.
nature of it is like it can ruin lives.
Oh
very
yeah,
easily,
but
and so that's
a much
it's like-
better way to fix that is to have it regulated. But you can't have
Well,
something
yeah, that's the whole
regulated
argument
and
of
illegal.
regulation versus
Yeah, when you
Yeah.
make something illegal, then you lose all power to regulate it. So, for example,
Yeah, it's a case of whether the like power to regulate is better than the power to like reduce
so
access, basically.
America went through its phase of banning alcohol. They swore it's not a phase, mom, but it was a phase, and so like, and so that's actually a big problem because when you ban alcohol, you also remove all of the rules, and
Yeah.
because of that, all of a sudden, minors drinking is just as illegal as adults drinking, and because of that, you will have like uh, more people at the age of like 14 drinking, because at this point it's just as illegal to drink as an adult as a kid. We should just make it
Yeah.
illegal.
I mean, a
Every
common issue
business, please.
with banning stuff in general is that it means that the ways to make it aren't professional. They're not proper, and so you end up with kind of junk
Yeah, precisely.
that like yeah, it's very common with drugs, but even with alcohol, like in prisons and stuff, they do all these roundabout methods of like making alcoholic stuff, but half of it's poisonous because these
Yeah.
methods are like not great.
If I do remember
And so yeah,
correctly, I'm pretty certain that like right now, when it comes to almost all of the statistics like public health, America, when it comes to drugs, is losing to Europe precisely because of the fact that in Europe we just have safer drugs. It sounds silly,
yeah,
but that's just like I think wait, was it Switzerland? It was either Switzerland or Netherlands. It's always one of these two, where they basically instead of doing a war on drugs, they uh started just helping people, which is crazy. Why would you do that? That's so what helping people. And so basically they give them the option to inject, I think it was heroin, inject heroin with you have like specific places to inject heroin with clean needles, stuff like these, and they basically made these places way safer, and because of that people actually went to these places, and they slowly, and there were actually professionals there who helped them, overcome their addiction and stuff like these. One thing is, so now they all of a sudden they don't have such a massive problem. I have a very selfish reason to not like it, and that's the fact that I just want to make meth. I don't want meth. I don't like meth. I really don't like meth. I just want to make it. I just want to make a YouTube video in which I make.
you want to make it? Did you say
I do want to make it. I want to make it happen.
you want to make it?
I always want to make it.
Make it wants to make it.
I do also want to make caffeine, but the process is so much more difficult than with meth. I just want to make some. I just want to do some organic chemistry. So for caffeine, if I remember correctly, yeah, for caffeine it's like really
For
annoying.
organic, I can help you with a lot of the fundamentals and like the theory. But then when it starts to like remembering reactions,
Yeah, I feel like
I'm
for
gonna be absolutely useless.
I feel like for organic chemistry, I'm not actually going to do a lot of theory videos because they will be just straight up boring.
Well, it
Would,
depends. You can like show things like how electron density moves around and how that weakens different bonds and makes things better or worse Lewis acids and that kind of stuff.
yeah, but still, it's more about the fact that electron density moves around than about specific examples. So,
Yeah.
it's kind of like with sigma bonds, let's say. Explaining how sigma bonds work is much more interesting than just giving different examples of sigma bonds. And in this case, explaining the electron density would be, well, I wouldn't explain it perfectly in detail. I won't explain anything perfectly in detail. There's too much detail. I'm not a chemist. So that would be like 10 to 15 minutes, and then everything else would be examples. That's why for organic chemistry, I mostly just do practical stuff. Like math. I
Yeah.
mean, no, I'd never. The government, I love CIA. Mwah. My Boeing is the great corporation. Set up methyl iodide. It can be used to make caffeine. Methyl iodide. That sound iodide. I never actually. I don't want to buy these specific things because they are expensive. They are really expensive.
I do kind of need to go now, I think.
Okay, it's fine. It's fine. I'll just keep on streaming. Bye, Flame.
Yeah, it's fine because you're doing organic anyway.
Yeah. I mean, I'll just switch to
All right.
probably animation as final, so video.
Yeah,
making,
let me
whatever.
know if you have any questions because I'll be like studying the. If you ask me a chemistry question, that's very chill.
All right. Good luck,
Um,
Flame.
See ya. Have fun.
Bye.
Bye bye.
Okay, now. No, I'm much larger. I don't fit in the cauldron anymore. Dag nabbit. In the kettle, sorry. There we go. The perfectly averagely sized kettle. Tefta, would you like to play some finals? We did the research portion of the stream. And I'm tired. Science is exhausting. Hold on, let me switch on an animation to run in the background. We mix steel brine and methyl iodide. I don't want to buy the specific things because first of all they are expensive, and second of all, there aren't actually that many things you can use them for. And because of that, like once I make caffeine, it will just stay there, and there will be nothing I'll be able to do with it. So I'm at work. That is fair then. All right, then give me a second. I'll be right back. I'm just gonna go. Be right back in like a minute. And I'm back. As what I told you, I'll be back right here. Okay, what are we doing now? What should we do? What shall we do? We have a couple of options. We could. I'm tired. I know we have a couple of options. We can. We can. We can do what? Well, we can. Let's make a poll. What are we to do? Just sit here and chat the finals and stream 3D animating. Those are the options. Go on and pick away, everyone. Democracy, yay! Theobromine is the main ingredient in chocolate. Oh, I could separate it from chocolate and make caffeine. Well, no, never mind. That will also be expensive. I don't have that much equipment, actually. Separating it would take some equipment. Just sit here and chat, really. Alright, then. Chat away. Carcinogen. Isn't just carcinogen like cancer making ones? You can handle them properly, I think. Well, everyone, we need a conversation topic then, if I'm just gonna sit here and chat. So what's the topic? Well, what are we chatting about? What's your daily routine? I wake up, I walk, and I walk some more. Then I usually either make myself some frozen veggies or I go out to eat. There's like a nice kebab place near me, which I do tend to use quite often. Then I walk some more. Then I usually stream. Then a little bit of walk to end the day off, and then I go to sleep. All right. Could coca leaves grow in Eastern European climate? Asking for a friend. I mean, where there's a will, there's a way. You can just match a climate, I'm pretty certain. Isn't that what, like, greenhouses are for? I think you can just make, like, a greenhouse for it. Oh, finals and 3D animating, betting with some more traction. That's nice. Half of the people left the stream. That's cool. Members got back. Hi, the Beyond, indeed. Oh, we just got back right when Flame left. Oh no. Probably in Indonesia. I live in the right climate. Ah, that's convenient. Crying on total synth sequences. How are they just that good? That's just. Wait, what happy? What they make it? Rat brain and human neurons. What do you mean? What could you possibly mean? That's a pretty odd way to start the conversation. Are you in university? No, I am not. I'm a generalist. Universities, I don't really go with universities. I'm awful at specializing, basically. So whenever it comes when it comes to like going really in depth on topic, I'm awful. I'm only good with like general overviews. That's why I do visualizing, because visualizing only requires general overviews, and yeah, I'm just really bad at going in depth. I've tried it before a couple of times, never worked. In computer science, in quantum mechanics, in physics, in chemistry, never works. My conversation starter usually is, did you know that you could make meth from styrofoam polystyrene? That's a solid way to start the conversation, I gotta say. Can't we just play like a finals in the background? So you make a living without specializing? Yeah, as in specializing in science, I mean specializing in science. When it comes to my living, I just make 3D animations. Like, I do that professionally. I guess that's my specialization. But I don't really like to consider one because it's not really science, so. Is my Spotify account got banned? It sounds like quite a story. This stream feels awkward. Yeah, because your pig just sit here and chat. And I'm just sitting here chatting. That's why it's awkward. I'll stop with the drugs. I like the Beatles. What kind of band do you like? Absolutely every single one, no exceptions. I like you all to challenge me on what I wouldn't like. I just like all music. I just like music, period. And anything from AJR through the Queen to fentanyl. Which is about as wide of a range as I can think of. Try listening to Wild Honey Pie by the Beatles. Wild Honey Pie, I don't know those songs all that well. I mostly just know AJR or Stipendium. What AI generating make it? I don't know what. I don't really get. Oh, you're trying to pull a topic. That's very broad way. No head of Master Boot Records here. Really great. AI is pretty overhyped, not gonna lie. A bit. It depends on the area. In certain areas it's underhyped, in others it's overhyped. It's almost never hyped quite enough, you know? When Flame left, just people went with him. No, like we generate. Oh, you want me to generate some make it's? Maybe. How hard is it to make a living out of animation? Not that difficult. Depends on the kind of animation you do. I can't say for the actual animators, you know, like Disney kind, you know, so the actually good ones. I mostly specialize in visualizing and ads. When it comes to ads, it's pretty easy because it's a soulless job. No one wants to make ads. I don't want to make ads. It's annoying. You feel that you're making the world a worse place. Yeah, it's a bit gimmicky to me because it only knows like Wikipedia stuff. Well, that's kind of the point of AI research, right? To make AI which can actually reason. The better AIs, the better the reasoning. So yeah, all of the answers are very vanilla, but that's mostly because it like kind of huge asterisk attached averages the answers out. So you'll get like an average answer for a thing. And usually the way we humans do it is different, where we like switch up the answer style based on the answer type in a very complex way. Yeah. Well, predictive models are very far from reasoning. Are they really? I wouldn't say so. I wouldn't say predictive models are very far from reasoning, because that's kind of what humans are, isn't it? Predictive model. It's just that we humans, had a much better, like our learning system was much better because it went on for a really long time and it went on with extremely high quality data because it literally went on the learning data was the real world. So it's like about as good as it can get when it comes to learning data. So I would say predictive models are on the right track when it comes to reasoning. It's just that life had a lot more time and a lot better data. Predictive models are very good from reasoning. The better the reason to use AI to reason, yeah. The answer tastes like boiled chicken. That would be my analogy. Boiled chicken. I mean, I guess that's a surprisingly good analogy, actually. Hey, am I too late? Is the stream ending? No, people just picked. Everyone just picked sit here and chat, and that's what I'm doing. We don't know how the human brain works, though. We do know how the human brain works, though. That's not a. We are only our brains. Yeah, that's my claim really often because like based on the science, based on the current research, we are only our brains. I've been watching some biology videos these days, so these topics are stuck in my brain. There's like one really good biology channel which stopped making videos 3 years ago, and so I'll decide this might usually get lost with YouTube. Well, if I would suggest switching up a source because a good source will be able to explain anything without it being boring. But yeah, we don't know how the human brain works. That's a bit of a misconception because we don't know, because that's, well, it's not really a bit of a misconception. It's a very vague thing to say because like we know the underlying methods, right? We know how neurons work. It's just that there's emergence. So basically, multiple neurons work differently than singular neurons. And that's, you would need to specify it more to what actually you mean, because that's a very broad thing to say. We know a huge chunk about how our brain works. How's funny? I'm a senior in high school. Yeah, just switch up a source until you find the one that clicks. The only thing that AI can do is economy, because that was its first use. I mean, there are a lot of things AIs can do. It's just that the AIs that actually do good things is that they aren't that popular. We haven't mapped the connections yet for humans or any large creatures. Yeah, that's why I meant that's what I meant by like, you would need to specify it more, because saying that we don't know, but neurons aren't the only component. Well, yeah, but like we know all the underlying mechanisms. And I'm having trouble figuring out a good analogy. It's kind of like economy, all right? When it comes to economy, it's kind of like saying that we don't know how economy works. Which, yes, we can't really figure out exactly what the economy would look like, but we know the basic rules, like what human behavior is like. That would be kind of analogous to the neurons' behavior. And we know some high abstraction level rules, right? So we know the general rules for how, supply and demand, for example. And when it comes to human brains, we also have chunks of brains. We know that they are responsible for different things. So that's why, for example, you can make an MRI scan of someone, and based on that MRI scan, you can figure out certain aspects about their brain. But we can't really figure out exactly what the reasoning will be like for the brain, and we can't figure out exactly what the economy would look like at the very end. So we do know a huge chunk about how their brains work. We just don't know it with... We have a lot of accuracy and a lot of precision. Is that like good? I feel like that's a good one. Good enough way to describe it. Hey, make it. How do you know that we are controlling our brains or our brains are controlling us? I don't know this. I just base it off the current like theory because that's a possibility that we are controlling our brains or our brains are controlling us. But that would mean that like all of our medical research is wrong, you know. So that is a possibility, but it would basically just mean like that the whole study of neurology we'd have to throw it out the window. You've already heard what the frontal lobe is, and we know precisely. Yeah, that's a phenomenal example. Like we divide them into lobes, so right brain, left brain is also like a very simple. Like we can the fact that we can separate the brain to right brain, left brain is phenomenal because that's something it doesn't really happen often with complex systems. We can make lab-grown brains, yeah. Knowing the rules, I mean, AIs are, I suppose, are technically like lab-grown. We can make lab-grown brains, and AIs will be like lab-grown minds, I suppose. Knowing the rules does not mean we know anything about brains. That's like saying if you know on and off, you know all of programming. You misunderstand what I mean. So, here's the thing. Imagine, if you will, that you are doing chemistry. And in chemistry, imagine, if you will, that you have a bucket full of water, H2O. And imagine, if you will, that you submerge two different cables into it. Well, no, that's not a good example. This is something a bit more fun. I don't know that many. Okay. Manganese dioxide, zinc, and potassium hydroxide. I feel like that would be a better example. So imagine, if you will, that you have a box with three things. Zinc, potassium hydroxide, I forgot what the symbol for zinc is, and manganese dioxide. Am I getting these symbols at least partially right? Because I don't know. ptable.com. First of all, zinc is Zn, right? Potassium and manganese. Is it Mn? It is Mn. Oh, look at me go. So, what we would expect to happen is we expect a reaction to occur where basically we would be moving charge. I think this way. I don't know all that many chemical reactions to actually make this example work. The point is, we can figure out what's going to happen at the level of individual particles, right? We can figure out what's going to happen. We can figure out that if we plug in the wires at the very end, we'll have the basically electricity flow, right? We'll have electricity in the wires. But we don't know what's going to happen exactly because there are straight up too many particles for us to simulate. But still, there are some general rules we can follow, and that's why we know that net effect will be electric charge moving. For our brains, it's the same thing, except our brains are much more complex. And because of that, the net effect won't be as clearly visible. It will be obscured by a lot of abstraction. But just because we know underlying rules, yes, we can like figure out everything about the brain. Is that right now we just simply do not have the means to figure all of this out. We don't have the means to simulate all of neurons. Well, we do have the means to simulate all of neurons, but we don't have the means to analyze them. That's what I mean. So, as ethanol draft 5% reactions, is that what you mean? I mean like how you can have a lot of particles, but just by knowing underlying rules, you can predict the effects, even though there are quadrillions of particles, stuff like this. I'm studying unique physics books, since you explain just state facts and laws without driving anything. Mething or unibooks just suck? Unibooks just suck. Yeah, they do. They really do suck. Because there is always a reason for the rule. Even with elementary ones, they just usually say it in red like, this is an elementary rule. More like unibooks suck, precisely. That would mean that we live in a simulation if brains are controlling us. Not really. No, brains aren't controlling us. We are the brain. So, how should I explain this? You think, right? We all think. Right now, we're all thinking, we're all conscious. At least I'm assuming. I have a sample. To be fair, my sample size is 1, but I feel like it's a pretty safe assumption. I don't really have any evidence against it, so let's just have it as an underlying assumption. We're all thinking right now. Now, since we're all thinking, right? Thinking has an effect on the real world. You can move your hands if you can think. And the rules of our universe state, the current rules that we think are true, state that if you have a force which is acting one way, then if you have an object, I'm thinking of a good way to explain it without actually overcomplicating things. This is actually pretty difficult. You can't have something only act one way, right? If you have two things which repel each other, then they're both gonna repel each other. If you have two things which attract each other, then they're both gonna attract each other. You can't just have something go only one way. Which means that if we, as our thinkers, right, as the thing that actually thinks, can move our arms at will, that means it goes both ways, right? Which means our arms also have to affect us. And what that means is that us, the actual thinking us, our actual mind, has to be physical. It has to be. Because otherwise, this wouldn't work. Otherwise, this would only go one way. And if our mind is physical, then the question basically becomes, which part of our physical body is responsible for thinking? And based on the current theory, it would really seem like it's the nervous system. Yes, the nervous system is being influenced by the rest of the body, that's true. But if we really wanted to separate it, then our nervous system would be the way to go. And so that's why we are our brains. If you believe that we are more than our brains, that's obviously fine. But it's just that I'm talking like from a scientific perspective. Manganese dioxide, like the selective oxygen for ionic alcohols. Manganese dioxide, that's just an alkaline battery. I think, therefore, I am precisely. Yeah. Then, how about my understanding? Are there any suggestions for physics? Well, physics depends. For physics, I don't know really all that well. I would recommend. Oh wait, I forgot the name. A library text. That's what I would recommend. Librarytext.org and platforms, libraries, and then go into physics right there. This is what I would recommend. Let me just paste it also in chat. There we go. Is sentience distinguishable from complexity? Well, that's where we go into the difficult bits. Because right now we can only at this point, we can only guess. We haven't actually done enough research because actually researching and analyzing complex systems is an unbelievable pain. And so far, AIs are kind of our only tool to analyze complex systems. Apart from AIs and our brains, there isn't really anything else we can do to analyze a complex system. And our brains that's about as complex of a system as you can get. I'm pretty certain, I've seen it stated a lot, that our brains are the most complex system we've ever seen. And our, the depends on what's it called, is the second most complex one. So yeah. Any cool YouTubers you'd like to advertise for Tefta and Soda? I wouldn't call Tefta a YouTuber because yeah, Tefta does have a YouTube channel and you all should go and subscribe, but calling Tefta, it feels like an insult in comparison to what Tefta is doing. Tefta is doing so many cool things that calling Tefta a YouTuber, that feels like an underhyping of sorts. But yeah, everyone, subscribe Tefta on YouTube. Program chemistry takes finds out courses online for physics. That's why I hate philosophy. Just let me have my little organic molecules. I also don't like philosophy. The reason why I don't like philosophy is I believe that it really often claims to be grounded than science, and because of that you basically throw the scientific theory out the window. And me, as a science cultist myself, I can't accept that. As a science cultist, I cannot accept you throwing the science out the window. That's just disrespectful. Nice watching by the random space enthusiast. I think less sources on physics, but I've not researched that. What's a realistic air resistance, and how many fast per second does a human need to do vertically upwards to reach a constant velocity of 5 meters per second? I don't know, like, fast per second, it would be an awful way to measure it because you're not actually accounting for the force generated by the fans. You would need a thrust, which basically means you would need like the actually quite a lot of things that fans could affect in this case. So yeah, just fans per second, that's not good enough a unit. Come back with a better unit, then we'll talk. I just want to know since do you use Linux? I did. Technically I do on my laptop. It's great for like practical uses, but right here I just use Windows because I have Adobe. So kinetic force of fact, precisely. Using the kinetic force, not actually. Yeah, right here on Make It Streams, we talk about the real issues, the real problems, like the fat acceleration. A fat is 1/10 of a Newton upwards. Well, that's a simple question then, isn't it? Wait, hold on, that's a very simple question. If you like have the actual number in newtons, that's unbelievably simple. So you were saying velocity of 5 meters per second. Okay, so v is equal to 5 meters per second. I haven't done physics in a while, classical mechanics. So this is gonna be a wild ride. 5 meters per second. And then you have, so then you would have the mass, which is an x, right? We don't know what the mass of a human would be. And correct me if I'm wrong, a is equal to mf, if I do remember correctly. Increase the force, increase the acceleration. No, this doesn't make sense because then you would increase the mass. Am is equal to f. Increase the mass, increase the force, increase the acceleration, increase the force, precisely. And then acceleration, you would basically want to reach 5 meters per second. It would also be of time. So it wouldn't really, oh, unless we're accounting for gravity. Obviously, we have to account for gravity. Could you adopt a bird, make it? I don't know. A parrot, maybe. In the future, we'll get a parrot, but right now, I don't really have the funds for that. Also, I know. When all of us released at the same time, though? No, we're doing it in fast per second. So we're trying to get W is equal to Fs, so F is equal to walk divided by force. Walk? I mean, I suppose you could do it walk. That feels like a roundabout way of doing it. You just rewrite AM is equal to F. Yeah, because the first time I just did wrong, the other way. I don't remember all the equations for physics. I just, make them up on the fly. That's horrible. I'm not a physicist. Right. I'm just a messenger. Alright, gravity would be equal to force of gravity going down. So the gravitational acceleration, so that would be mass of the first one, mass of the second one divided by r squared, if I remember correctly. If I do remember correctly, it's this. This I'm doing from memory. That's acceleration. Now the force of gravity basically would mean this. Force equal to am. No, this doesn't make sense. First object, second object. Second object is constant, that's the air. So we could just add this to the G. We could just have a capital G of F. Just to combine the constants together to make it a bit simpler. M1 are this. Focus on genetics to upgrade the human race, then we focus on other realms of science. I myself, okay, I'm not a huge fan of that because genetics, I'm not a huge fan of that. I mean, I am a huge fan of genetics, of course. I'm a science cultist. I love all science. But I feel like a much better way to improve humans is to do it with, I think electronics is much better simply because it's better optimized when it comes to moving energy around. Photoelectric effect basically is the quickest way to move energy and turn it then to electricity, and electricity is the most efficient way, so you lose the least. In my opinion, you lose the least on average when it comes to all applications. Because when you think about it, like, life uses chemical energy and thermal energy. And whilst chemical energy is fine, thermal energy, that's bloody awful. That's the worst kind. Yeah, electronics is better, but I think it would be more difficult. No, it wouldn't. We can already do that. What do you mean? Listen, Happy, what do you want to upgrade? Let me ask you this first. What would you like to upgrade about humans? Just give me an example. Right? Obviously, there's like a lot of things we could upgrade. Immortality, we could stamina for breathing, for example. Muscles, we can just have them sweet robot limbs. The robotic race of superhand religious conservative people will hate it. Religious conservative people hate it, and they would love genetics. Lifespan. Yeah, so for example, lifespan could be very easily improved with electronics because it's basically easier to replace an electronic part. So whilst, yes, organic things can regenerate, electronic things you can replace, and that's much more efficient. That's why, for example, we have factories to make things instead of making them each individually. So in that case, you could basically have a factory of artificial human limbs, and then you can just replace your limbs as often as you'd like. Immortality is a myth. Why? I don't get that. I really don't. I want to upgrade the brain and immortality. Upgrading the brain, that's very cool. I would love to switch up my brain for silicon. But in order to do that, I would first need to make sure that, like, you know, brains can work with silicon. And that would require a lot of research, so. Immortality is a myth. I really don't get that one. So, force equal to 1/2. That does seem correct because, yeah. But like, if you wanted to be immortal, it would be easier to change genetics than to move the brain to something immortal. Oh, really? Have you considered the fact that, like, if you change genetics, then it's actually unbelievably difficult to change up the genetics of your own body? Have you considered that one? How do you replace the genes in your own body? What, are you gonna make cells which, like, replicate themselves over your current ones? I mean, that's fine, but then you have to somehow get rid of all of your current ones. You're gonna trigger an autoimmune disease to, like, I don't know, kill off all of your current cells so that then they will be replaced with the new ones? That's it, replacing stem cells. Okay, but the old cells will still be in your body. You still have to somehow get rid of them. You can just wait, but the entire time you wait, you're not immortal. And that process could take decades. Just got here, what are we doing? We're just chatting. Really picks. Alter the code of cells. You can alter the code of a couple of cells easily. But you're not really going to replace the genes in all of your cells. It would be much easier to just, you know, make synthetic ones at this point. I should go now. Well then, good luck, Yimsok. Shed them. Make it you vegan, not vegan. I don't think I'm vegan. I do eat a lot of veggies, not a lot of meat, but that's mostly because meat is expensive. I would love synthetic arms, so would I. Can you imagine? With synthetic arms, I could basically, you know, throw away all of the unnecessary bits, like blood flow, you know, blood vessels, all of the unnecessary bits, like bone, stuff like these, and just replace them with pure efficiency. Can you imagine how strong you would be then? So there's just animals that can regenerate arms. Yes. There's quite a lot of them, actually. I think starfish, I think ocelots. No, wait, it wasn't called. There was I don't remember. Almost killed myself today. Please tell me you mean by like an accident, and I'm glad you didn't. What happened, lamppost? Oh no. No. This region is good. I feel like a replacement is better than region. No, an accident. Show me the arena. Lamppost, for fuck's sake! You no. Why? Why? No. Okay. That's not. No. Why? Lamppost. Come on. Why? No. For real, don't do it. It's like a mile way to put it. Lamppost. Please tell me you won't do it again. This is serious. Relax, Maggie. How am I supposed to relax after that? Okay. Okay, so here's the thing. There are healthy ways to cope. Because yes, I won't sit here and be like, oh, look at the bright side of the light. Because that's just a pointless thing to say. Yes, it is, but please, I beg you. I just at this point I just beg you. There are healthy ways to cope. There really are. And I know it's awful. I know, but do you have access to like a psychological medical professional, something like that? Could you like get someone? You know, psychologist, because that would be just a better way. I'm sorry, I'm just a bit. again, so I have to over-explain things. They doesn't know. I don't really want to understood it. So here's the thing. Wait, but you do talk to her. Did you talk to her about this? Because this is serious. So I just really don't want you to get the "oh, I'm fine" mentality. It really is important for you to share it in a healthy way rather than, you know, the unhealthy one. Did you talk to your girlfriend about this? Because I feel like it could really help you to have like a deep conversation with someone. Maybe. Most importantly, the best thing for you to do. No, but I'm just gonna take on stress. Okay, no. See, that's the problem. That's the problem. You're getting into the "no, I'm fine" mentality, and it's gonna take a lot of stress. That doesn't really matter. Listen, lamppost. No, that's really dangerous. That's really dangerous. Tell her about this. Either tell her or schedule an appointment like a psychologist with, you know, with a medical professional, and then tell her about this. Because trust me, if she really cares about you, and I think she does, then this she really won't mind. That's all I can say at this point, because that's all there is to it. She really won't mind. So please, either a medical professional or her, or ideally both. I know, man. That was 900%. That's precisely the problem. I know. I know. Bottle up, and then at some point, there's like a feeling you get whenever you want to share anything. I know. I understand. But you have to understand that, like, if you don't, then this will lead to. If you tell her, then you'll just be honest. Okay? And being honest will be. Can't tell her now. She's in charge of her exams right now. I'll tell her after exams. I didn't do anything. Okay. Will you really tell her? Do you promise to me right now? Are you going to promise to me right now that after her exams you will tell her? I need you to promise. I really do. Yeah, I promise. I'll tell her everything only after once. Okay. Now, I want you to realize that a part of that promise, you will tell her, means you will live long enough to tell her, so please just hold on until, well, ideally, I still would feel much better if you would go to a medical professional, because that would be a better way to do it. But I do hope you will do what you promised. So yeah, having one corner is a bad thing, but there is a corner, and it's a cycle. It's always a cycle. Always feel bad, and because of that, you only you feel bad because of that. Your life gets worse because of that. You feel even worse that your life getting worse. It's always a cycle. So, the important thing is to start small with this one corner. And that's why I think it's so important, Lamppost, that you actually do tell her, because it will make you feel better. And because of that, a medical professional therapist couldn't pay for days of time for months, only 2 days, and their team told me to kill myself, so I'm never gonna trust them. That is so fucking. Okay, then your girlfriend then. And I just then just tell her, and then you'll get this weight off your chest and use that as your your turnaround point. For profit mental health. You know what? That doesn't matter. Therapists, from what I've heard, you know what? From what I've heard, actually, therapists aren't a key thing. What's really important is that you do have someone, because that's just tell her, okay? That's it. Once you do, you will feel much better, and I'm really hoping that was just like a one-off. Yeah, I'm in the hospital. People forcefully made me admit here. Counted 2 days later. I'm really glad. I'm really glad you will. And honestly, I am glad you're at the hospital right now. 'Cause and I'm trying to realize, yeah, it's basically a pretty awful situation. Maybe need something we obviously are here, but I really think. I just want you to know that if you stop responding, I will feel really bad. So, there's my attempt to blackmail you too. So, the issue here, Lampos, the main issue is that you basically don't want to annoy other people with your feelings. But what you don't realize is that that's like, if you tell this to your girlfriend, you're not really going to stress her out. Well, I mean, you will, obviously, but it's not going to be that sort of stress that will make her feel bad. She will actually be really glad to help you. So I just really want you to understand that, because that's really important. You won't really be making her life worse. If you tell her, you will feel better, and she will feel better because she helped you. So Please. Just really, it's important, okay? Okay. You promised, so that's all that matters. You're not a burden, lamppost, okay? Just remember that. To other people around you, you're not a burden. Don't think of yourself as one. Definitely. Bye. Bye, lamppost, and I really hope to see you again a lot of times, okay? So, you know, I really do hope. I'm gonna go now too. In the stream. And I really hope you, on the end of the process, because as I mentioned, you're not a burden. Don't think yourself as a burden. People around you will be happy to help you. That's most people like helping others. So yeah. I don't like the way we end on, you know, that sort of negative topic, but this was important. Anyhow, good luck with your surgery, lamppost. And for now, be it.